So continuing from yesterday, parallel and perpendicular lines. We have symbols and something that we need to know about the slope. So this is still just review from Algebra 1. What is the symbol for parallel? Yeah, you're making the hand symbol. There you go. And what do we need to know about the slope for parallel lines? Not 0. What has to be true about the slope for parallel lines?
Either the x or y has to be equal to each other.
No. Okay, how about this? What has to be true about parallel lines in general? They never cross. So if that's the case, then what has to be true about the slope of parallel lines?
They have to be equal.
They have to be the same. Yep.
Little.
If the slope of two lines is different in any way, then the lines will cross, guaranteed. So they must be the same slope in order for the lines to be parallel, for them to never cross. All right, what's our symbol for perpendicular lines?
The upside down T, right?
Upside down capital T, yeah. There you go. And what is true about the slope of perpendicular lines?
Opposite reciprocal.
Opposite reciprocal, that's right. What does opposite mean? So what does opposite mean, though? You can't say opposite sign if you're trying to define opposite. Like one's positive, one's negative. So change the sign, okay? What does reciprocal mean? Nobody knows what reciprocal means? Well, flip the number, yeah. So if you had 4, now it's 1/4. If it's 2/3, now it's 3/2, right? So that's what a reciprocal is. So change the sign and flip the number, okay? Both have to happen. All right, so to find the line parallel or perpendicular to a given line. So this is the steps for both, parallel or perpendicular. First, determine the slope of your new line. So these problems are going to ask you to find the slope, or find the equation of the line that is, fill in the blank, to the given line and passes through this particular point. So determine the slope of the new line. What is your slope supposed to be? Is it parallel? Well, it's the same slope as the original line. Is it perpendicular? Well, then it's the opposite reciprocal slope of the given line. Then plug in the new slope and the point that you were given into point slope form, just like we were doing last time. And then probably you'll have to put it into slope intercept form, and then you're done. Okay? These are very straightforward problems. You just have to know what the original slope was. That's all. All right? So we can practice. Write the equation for the line parallel to this equation through this point. So what's the most important word here? Parallel. As soon as I see the word parallel, I need to know that I need the same slope as the original line. So what is the slope of the original line? It's 6. So what is my slope supposed to be then? 6, because it's parallel, okay? So the first thing I'm going to do is I'm going to write down my slope, m equals 6. Now that I know that my slope is supposed to be 6, I have a slope, and I have a point that they told me to go through, I can write point slope form, okay? So I don't care at all about this equation anymore, the one that they gave me. That equation was only useful for the slope. Now it's done, I don't care about it. So we go on and write point slope form. So it's going to be y minus, and then my point is -3 for the y coordinate. So it's y minus -3, which turns into y plus 3, equals my slope, which is 6, times x minus, and then my point has an x coordinate of 1, so I write down 1. Okay, so that's my equation, point slope form. But we want to put it in slope intercept form. So to do that, we're going to distribute this slope. So we have y plus 3 equals 6x minus 6. And then we just get the y by itself on the left-hand side. So to do that, this time I'm going to have to subtract 3 from both sides. And I wind up with y equals 6x minus 9. And that's it. That's my equation. Now I want to point out a couple of things. First of all, notice that the slope here and here is the same. And also notice that the y-intercept for my line is not the same as the y-intercept for their given line. And it's also not the same as the y-coordinate that they gave me. Okay? You have to go through that process. You cannot take this y-coordinate and plug it here. Okay? Don't do that. You'll get it wrong. All right, so what am I going to do for the second one then? Perpendicular to. So what is my slope going to be? Has to be the opposite reciprocal. So what is their slope? -4. So what is my slope going to be? Positive, because theirs was negative, and then flip the number 1/4. Write that down, okay? If this was a test or a quiz and it's worth multiple points, you're going to get a point for that. Now go on. We have our slope and we have the point that we're supposed to go through. So now we can write our equation in point slope form. So what is it? Y what? -5 equals
1/4 parentheses x minus 2.
x minus 8. Okay? Notice that I don't care at all about that y-intercept. It's garbage to me. I don't care. Okay? Now what? Okay, so I have y minus 5 equals 1/4 x, and what's 1/4 times -8? -2. And then we're going to add 5 to both sides. So that gives me y over here equals 1/4 x, and I added 5 to the right-hand side also. So +3. Done. Okay? So, most important word in this problem, perpendicular. Once I saw perpendicular, I knew I needed opposite reciprocal of that number, which was positive 1/4. And then I went from there. Okay? Otherwise, it's the exact same problem. So, what is the equation for each line in slope-intercept form? We need the line parallel to this equation through that point, and then the line perpendicular to that equation through that point. So, if we look at the one in A, what's up in that one? We want parallel.
Oh, yeah.
Yeah, what's wrong?
It's not,
It's a standard form.
It's in standard form, and in standard form, remember, ax plus by equals c. The slope is not present in that equation. We need to put it in slope-intercept form first so that we have the slope obviously visible, okay? So, off to the side, I'm going to try to put this in slope-intercept form, okay? What would my first move be?
Subtract 4.
Yeah, I want to get y by itself, so we're going to subtract the 4x from both sides, right? I'm just going to show you that right there. So then what do I have? 2y equals -4x plus 7, yeah. Okay, and then what are we going to do?
Divide by 2.
Okay, so I'm going to show you that, and really at this point you still should be doing this. Divide by 2, but everything gets divided by 2. So divide by 2 and divide by 2. Okay? Now the y-intercept we don't really care about. It's the slope that we care about. So this is just y equals, this is really just -2x. And this over here is 7/2, but that y-intercept doesn't matter. All we care about is the slope. So what is our slope? -2. So what is the slope of the line that we're going to write going to be? Also -2, because we want the line parallel. Okay? So for part A, I'm going to write m equals -2. Okay? I took that work to figure that part out. And now, on a test or something, I'm going to get 1 point because I just figured that out. Now I can write the equation. What's the equation going to be? Y plus 2, because really it was y minus negative 2, equals, okay, times
X minus
x minus
4.
4. Yep. Now, the directions told me slope-intercept form, so am I done? No, I gotta put it in slope-intercept form, which is really not hard. I just gotta distribute first, so y plus 2 equals negative 2x, what?
Plus 8,
Plus 8. And then
subtract 2.
subtract 2 from both sides, so that's gonna give me just y on the left equals negative 2x, what?
Plus 6.
Plus 6. I subtracted 2 from both sides, so subtract 2 from 8, plus 6. Okay? Everybody with me? All right. So now B. The line perpendicular to this equation through that point. What are we going to do?
Opposite reciprocal.
Opposite reciprocal slope, perpendicular, right? Do we know the slope in the original equation, or do I have to do what I did before? I know it. Okay, so what's our slope going to be? I'm going to write that down. M equals negative 3/2. Okay, so now I know my slope and I know my point. So what are we going to do?
Put it in.
Put it in
Right, so what's the equation?
y is
Yep,
negative 3/2
yep.
and just the x.
And really it's x minus 0, which I'm going to write for video purposes, but yeah, just x. Okay? Now what?
Add the slope.
Distribute and get y by itself, yeah? So really this is just x here on the right hand side, so really we just have negative 3/2 x, so y minus 6 equals negative 3/2 x, and then what?
6.
Add the 6. So it's y equals negative 3/2 x plus 6. And you're done. Okay? Follow that process. Remember that the number that you're given for the original y-intercept is not the same as the number that you're going to wind up with in the final. Okay? Don't just take that number and put it on your equation in the end. It doesn't work. Okay? You have to go through that process. That's the most common mistake on these problems. Okay, so that officially finishes the original section. Now, if you notice on your homework, I also assigned like 1 through 4 on page whatever it was, right? So that means we have these piecewise functions that we have to learn. So piecewise functions are kind of a favorite of YTOP and ACT, so your standardized tests. So at this point, we need to learn them. I do have a typo right here, so we'll just cross off the first f of x equals. Piecewise functions are called that because they are functions, but they exist in pieces. Okay, when you look at the graph, there's parts to them. There's like a chunk of a graph, and then a break in the graph, and then a chunk of the graph. Okay, so if you think of it like that, then the name piecewise kind of makes sense. So the steps here are graph each piece separately, and then apply the condition to each piece. So what I do when I teach these is, at first, I show you kind of how each piece lives, and then apply the condition that shows you where the piece is actually being graphed. Okay? What I mean by that is this. F of x equals is my function. Okay? Now, f of x equals the top piece is one function, one part of the function, and then f of x equals the bottom piece is the other function. Okay? So we can think of this as two separate functions kind of being put together. One function is alive during one part as we work our way across the graph, and the other part of the function is alive during the other part as we work our way across the graph. So now what we want to do is we want to think about f of x equals the top part. Remember that f of x is the same as y, so like y is the same as f of x. Okay? If I think of it that way, then f of x equals negative x is the same as y equals negative x. So if I graph y equals negative x, how do I do that? Where do I start? On the origin, the y-intercept is 8, okay? And so I would start here, I put a dot, and then my slope is negative 1. So I go down 1, right 1 a whole bunch of times, put a dot each time, and then I go up 1, left 1 a whole bunch of times. I'm not going to draw the line yet, though. What I just did is I showed you where this function lives, okay? If I drew the line, now we just have y equals negative x. Okay, it goes forever in both directions along that line. But I don't want to do that because right here, I have this condition. It says I'm actually only going to graph this piece when x values are less than 0. The x values that are less than 0 are on this side, the left side of the y-axis. Okay, so this top piece here only exists for the x values that are less than 0. Okay? So that's not part of the graph. I just drew that on there so you can see it, right? These are x values that are less than 0 on the left side of the y-axis. So only the part of the graph that I just put down there, that part that's on the left side of the y-axis is what I'm going to actually graph. So when I go to draw my actual line, I'm going to start where x is 0, which is on the origin here, and I'm going to draw my line to the left. Not up, to the left. Okay? There's a difference. So it goes forever to the left, but not to the right, past 0, because I'm only going to be able to graph this for when x is less than 0. Now, can x be exactly 0 or no? No, because it doesn't say or equal to on that x is less than 0. So that means I'm going to have to represent that with an open dot, just like we do on a number line. Okay? So now the second piece is this guy down here. F of x is equal to positive x. Now remember, y is the same as f of x, so I'm going to pretend for a second that this is y equals x. So where does y equals x live? How do I graph y equals x? Where does it start? On the origin again. And then it goes which way? Up 1, right 1 a bunch of times. My slope is 1. And then I can reverse that, down 1, left 1 a bunch of times. Okay, so if I was just graphing y equals x, this is what I would do. But I'm not graphing y equals x, really. I'm graphing y equals x, but only for these values. X is greater than or equal to 0. So greater than or equal to 0 starts at the y-axis and goes to the right. X is greater than or equal to 0. Okay? So that means that this piece that I'm trying to graph will start when the x-coordinate is 0, because I can actually be 0 on this one. And then all of the x-coordinates to the right of 0 will get graphed. Okay? So in this case, when I go to draw my line, I'm looking at only those x-coordinates that are greater than or equal to 0. So I will start drawing my line at 0 and go to the right. Not up or down, to the right. Okay? Now, in this case, can I actually be 0? Yes. So I will put a solid dot at 0. And what happened here is because those two dots, this empty dot and the solid dot, are actually exactly the same place, the solid dot filled the empty dot. So there you go, there's your graph. These extra dots down here were not needed because the original function didn't allow for those original pieces to be graphed down there. Okay? So that's it. That's your piecewise function for this particular graph. So let's take a look at this one now. We have f of x equals the top piece, negative 2x plus 3, and the bottom piece, x minus 1. And notice the condition. We're going to be broken at x when x is 2, okay? So the first thing you do is you're going to graph the top piece when f of x is negative 2x plus 3. So just treat it like you're graphing y equals negative 2x plus 3 in general. Where'd we start?
Negative 2.
We would start at the y-intercept of 3,
And down to.
and then the slope is negative 2, so we go down to right 1 a bunch of times, and then reverse it up to left 1 as much as we can. So this is where that piece is going to live, but where are we actually going to graph it is the question.
To the left side.
Where are we starting?
From 3.
Not from 3.
Oh, from 2.
We look at the condition 2. Okay, so when the x coordinate is 2, which is right here, okay, that is your x coordinate of 2. We go to the function from 2. The function is down here, and it says less than, not less than or equal to, so we're going to draw an open dot. And then less than is to the left. So we draw to the left. That's less than. Because it's to the left. Those x coordinates are less than 2. Not the y coordinates, we don't care about them. It's the x coordinates that we're graphing. Okay? Got it? All right. The second piece. F of x equals x minus 1. Just think of it as y equals x minus 1 and graph it. Where do we go? Okay, so we start at negative 1 right there. And then we go up 1, right 1 a bunch of times. And we could go down 1, left 1 a bunch of times. So that's where y equals x minus 1 normally lives. But where is it going to be actually graphed for this piecewise function?
2.
We're going to start at 2. So again, we go to where 2 is on the x-axis. Then we go to the function up or down. In this case, we're going up. Can we be 2 on this piece? Yeah, because it says or equal to, right? So we're going to put a solid dot. And then greater than 2 means we're going to graph all of the x values that are to the, which way? To the right of 2. So when we go to draw our line, we're going to hit all the x values to the right of 2. So this, it didn't draw my line. Still is not drawing my line. Draw my line. Draw. Come on. Still draw my line. There we go. That's to the right of 2. Okay, now that's your piecewise function. Notice that they're not connected. You can see the separate pieces very nicely. We see where we can't be. We see where we can be with the solid dot and the open dot. This is what piecewise functions usually look like. Now, to have a function, we know that we cannot have repeated x values. Do we have any repeated x values here?
Yeah, 2, right?
At 2 would be the only concern. And because right here we have an empty dot and here we have a solid dot,
No, we're good.
this is good. We have a function. Okay? And that's why it's able to be called a function. So if you look back at your graph and you see overlapping graphing, parts where you graphed and it was overlapping, you don't have a function. You did something wrong. Okay? All right. So now we have step functions, which are also actually officially called greatest integer functions, but they graph like a staircase. So that's why some people call them step functions. So to graph a greatest integer function, you're going to set up an xy table, and then record values by choosing smart x values and identifying the greatest integer to the left of your number on the number line. So this is what the notation for a greatest integer function looks like. It's basically 2 brackets. On both sides, not like an absolute value. So you could do this, like 2 brackets like that. So when you see that, what you want to do is set up an XY table. And then I said, choose smart X values. Smart X values does not mean 0, 1, 2 like normal, okay? We want 0 is fine, but then something like 0.25, 0.5, 0.75, and 1. And then 1.25, 1.5, 1.75, 2. Enough to be able to reveal the pattern that's going on, but you need decimals to be able to see exactly what the pattern is. Now, identify the greatest integer, that's why it's called the greatest integer function, to the left of your number on the number line. So imagine you were walking along a number line from least to greatest, and the last integer that you passed is the number that you need to report for y, okay? So if I'm standing on 0 right now, and I'm walking from left to right, what is the last integer that I saw if I'm standing on 0? Is 0 an integer?
No.
0 is not an integer? 0 is an integer.
Yes, it is.
Okay, so did I see it?
Yeah.
So the greatest integer is 0. Okay. Now, if I walk along a little bit further and I'm standing on 0.25, what is the greatest integer that I've seen?
0.
0.
Oh, 0,
Because fractions
0,
of 0.25 are
What about 0.5?
0, 0,
And what about 0.75?
0,
And what about 1?
and 1.
1.
0,
What about 1.25? 1. How about 1.5?
1.
How about 1.75?
1.
How about 2?
2.
Okay. You see what's happening here? If I continue the table, would you be able to answer the rest?
Yeah.
Yeah, okay. So that's what I was saying. You do enough to be able to see the pattern, reveal the pattern, and then you don't need the table anymore, okay? Now we need to make the graph. So I have 0, 0 for sure. I have 0.250 for sure. I have 0.50 for sure. I have 0.750 for sure. Now those are just numbers that I picked. But if I picked any number between, any real number between 0 and 1, what would I get in return? 0, right? So actually what I can do is I can draw a segment over because I'm always going to get 0 in return. What happens when I get 1?
plus 1.
I get exactly 1, right? So I get 1 here. Now, the graph, the pattern here is showing me that I'm expecting to go across here, and because I jump and I get 1 instead, I need to show that I don't get 0 here anymore, I get 1. So because I definitely get 1 and I don't get 0 anymore, what should I show right here? I need to show something right here.
Yeah.
And it's not a line segment up. What's that?
Like an open bar.
An open dot, yeah, exactly. So I show an open dot showing that I broke the pattern and I don't get what I'm expecting to get anymore. Instead I jumped up. And now what am I going to show from 1, 1?
Another segment.
Another segment, because all of these numbers in between, 1 to 2, I'm getting 1 in return every single time. And then what am I going to do?
Another segment and switch up to 2. Or another
When I jump to 2 right here at this number right here, what do I got to do?
an open circle.
I add another open circle. And now that we have that, do you see the pattern?
Yeah.
So once you see the pattern, just like we saw the pattern in the table, we can complete the graph by repeating this pattern. So we're going to draw a segment over, open dot, up to a closed dot, segment over, open dot, up to a closed dot, and then just continue the rest of the way through. And as you do it, you can start to see how this is called the step function, because it winds up looking like a staircase. At the very top, there's a dot, and then I can reverse all of that and go the other way. So drop down to an open circle, to the left, a segment, and then an open dot. And then reverse it, and I'll just be quiet as I finish this. All right, we're almost there. There's a couple more things to do. Everybody kind of understood this one? These are on your homework. So we want to mail a book. The post office is offering a rate for postage by weight. Anything 1 pound or less cost $2.23. A package above 1 pound up to and including 2 pounds costs $2.58. A package above 2 pounds up to including 3 pounds is $2.93. Graph the situation. What would a package over 3 pounds probably cost? What should we do?
Make a list. That's why.
Just make a graph.
A table.
But if I'm going to make this graph, what should I do first?
Make an equation.
Don't need an equation.
Identify, make a function.
Label.
Wait, yeah.
I need axes first. Where are they going to go? Where?
On the arrow, at the tips of the arrow, but like Y on
Where are my axes going?
the graph,
On
See
one.
that?
in the center.
Do I have any negative numbers?
No.
No. So do I need to put the origin in the middle?
No.
No. So,
Bottom.
yep. I don't need these axes that were given to me. I can move the origin to the lower left corner. And once I do that, what is my horizontal axis going to be? What?
Pounds.
Pounds. Okay, so that seems to be the independent variable, so this will be pounds. And that makes the vertical axis what? Cost. Okay, now we gotta come up with a scale. So, anything 1 pound or less, so that would include 0. We're gonna start at 0. And we're talking about up to and including 3 pounds. So we gotta make it to 3 pounds. And then beyond, right? So, we have 14 lines here. What can we go by? 0.25 would be pretty good. That would be 4 lines for every 1 pound. We'd get to 3 pounds at 12 lines, right? So by a quarter of a pound. So here's 1, 2, 3, here's 1 pound. 1, 2, 3, 4, here's 2 pounds. 1, 2, 3, here's 3 pounds. Okay, what about the cost? Just go by quarters?
Yeah.
So we gotta make it to $2.93, which means $3. So we obviously make it to $3 if we do quarters, so by 25 cents. 1, 2, 3, here's $1. 1, 2, 3, here's $2. 1, 2, 3, here's $3. Okay. So how do we start? Anything 1 pound or less is $2.23.
So draw the line.
What line?
A second. Yeah, the
Well,
second
Cooper's
one.
thinking of it in his head right now.
A segment?
To show that if it's anything less than 1, it could be cost 20.
Does it include 1?
No.
1 pound or less?
Oh, yeah, it does.
It does include 1.
Yeah.
So up at $2.23, which is just shy of $2.25, right? Including 1 or less. Wow. Try to make that straighter than what I came up with. Now, are we including 0 on that?
Yeah. No.
Why not? Why not?
Because you're not gonna buy nothing.
Yeah, if it weighs nothing, I'm probably not sending anything, right? So open dot on the end of that, and where would I be if I have no pounds?
Had no money.
Probably no money, right? But we don't know that for sure, so I'm not gonna mark that. Okay, now what?
Now it's 2 including 2 pounds.
So up to and including 2 pounds is 258. So I'm gonna go to 2 pounds first, and then find 258. So 258 is just above that, so maybe here. And then what?
Up to the 1. Above 1 pound.
So yeah. And what am I gonna put above the 1 pound?
Just an open dot.
Yep. Because otherwise we drop down, right? So there you go. And then what?
It's pretty easy.
A package above 2 pounds up to including 3 pounds. So you want to do an open dot above 2.
Above 2 pounds up to including 3 pounds, 293, so just short of 3 pounds there. And then up to including 3 pounds, so I'll go to 3 pounds. We're including 3 pounds. Everything in between is that 293. Okay. So there's your graph. What would a package over 3 pounds probably cost?
320.
Why do you say 328?
It's going up by 35 cents each time.
It seems to be going up by 35 cents each time. 35 cents from here to here, and then 35 cents from here to here. So add 35 cents again, and what'd you say, 328?
Yeah.
Okay. So again, sort of a step function, a real world step function. All right. We got one more thing to do. Writing a function from its graph. So this is a piecewise graph. We have 3 segments that we can write linear equations for, and then we just got to come up with the conditions that make them alive. These are not difficult to do. You have all the information you need. You just start off with f of x equals, and then I open up a brace over 3 lines. Now there's 3 pieces. We have the first piece right here, and then the second piece right here, and then the third piece right here. All you got to do is come up with 3 equations, 1 for each piece. Okay? So it'd be like y equals, and then you need the slope and the y-intercept for each one. So the slope is easy to come up with for each one. What's the slope of the raspberry sorbet flavor one? -2? No.
No,
This
it's
one's
0.
going up.
It's just 0, right?
The slope is definitely not 0.
Well, oh, it's up, it's 2, and it's up.
It's 3.
The rise over run. We're going up 2, right 1.
Yeah.
So the slope is 2. So you're going to write 2x, and then what's the y-intercept? Plus, because it's going to be up here somewhere, right? Now you just got to try to work your way over to the y-axis. And we do that by using the slope. So you're going to go up 2, right 1, and run -2. Up 2 to, where are we now? We should be at 4 now, right? Right 1, and now we're at -1. Up 2, and now we're at 6, right 1, and we are now on the axis.
So it's 6.
So the y-intercept is 6. So you just work your way using the slope to get onto where the y-axis is, okay? And you don't have to draw like I did, I'm just trying to show you how that works. Now, where is this thing alive? So the arrow here tells us that this piece goes on forever in that direction, okay? So where does it start?
2
At -2, right here. The x-coordinate right there is -2, okay? So we're going to say, comma, x is forever that way. Which way is that?
Less than.
Less than -2. Now, do you want to say less than or equal to? It doesn't make a difference because they're all touching. So just pick one. Less than is fine. All right? But now that means on the next piece we're going to have to say or equal to because we have to include that part. Okay? So now the orange one. Write the equation. You need the slope and the y-intercept.
Down to,
Slope is
oh,
two.
You need the slope.
Slope is two. Negative two.
It's -2. Okay, you see it? We go down 2 and then right 1. So that's -2. So we have -2x, and what's the y-intercept? Yeah, you can actually see it. It's down here, -2. So -2. Okay? Now, where is this piece alive?
It's greater than or equal to -2.
Okay, so it definitely started at -2 and went this way. Forever?
No, it stopped at
And then it stopped at what?
negative.
What x coordinate? 0. It stops here. So it's only alive between -2 and 0. Now, previously, we've seen how to write that. We have -2 is where it starts, 0 is where it stops, x coordinates between -2 and 0. We put less than symbols like that. All we have to do now, though, is make sure that we're including the numbers that need to be included. We did not include -2 on the first piece, so we have to include -2 on this piece. Do you want to include 0 on this piece or no? We have a choice because they didn't tell us one way or the other.
Yeah,
So,
let's let
sure,
them.
we can include 0 on this piece. Which means because we included 0 on this piece, we cannot include it on the next piece. Okay? All right, the green piece. You need the equation. Slope and y-intercept.
Slope is 3.
Slope is 3, so we're going to write 3x, y-intercept is, it's also -2, so -2. Now, when is this piece alive? The x coordinates start here and go forever this way. We're always looking at the x coordinates for this. So where does it start?
Greater than
0. We're going to write x is greater than 0. Okay? When you're talking about these guys here, these pieces, and you're trying to define when they're alive, you're talking about just the x coordinates. Look at the x-axis. When does it start? Okay? And by the time you're done, if you notice the entire x-axis here, I have scribbled on now, but you can see that the entire x-axis has been drawn on. Okay? So that's how you do those. All right, so that extra stuff, the 1 through 4 on page 91, now you can do all 4 of those problems. It's very exciting. And we're done.
Very exciting.